Welcome all to this video lecture series. Now this particular video lecture series will be focusing on the backtracking approach of the well-known problems. Now you might want to surprise by looking at this, shortest path. Using the backtracking? Well, we already have algorithms for the shortest path. Like in the greedy we have just the shortest path. In the dynamic we have a kind of Floyd Watson. Then you will be surprised to see that why we want a backtracking approach, even though the backtracking will take much more time. Therefore I have designed this video lecture series that will tell you that a backtracking is kind of related with the other algorithm techniques, and that is the unique connection, the bridge between these two algorithm techniques that will be exploited in this particular video series. So let's start with, first let's start with what is the shortest path problem. Consider this particular graph. It's an undirected graph with all the positive weights. Now what we want is here, we want the shortest path from A to D. Okay, so we start, this is our starting vertex and this will be our ending vertex. It may happen that we have many intermediate vertex, that is possible. There are multiple paths that is possible, like I can go from A to B, then B to D. Other path that is possible here is from A to C and from C to D, that is possible. Now again the other path that is possible, well, A to B, B to C and C to D, that is there. Again other path that is possible, A to C, C to B, B to D. So like that we have a many path that is possible that will lead from source to the destination. Our task is to find a path from the A to D, but here we want is a shortest path. Shortest means in terms of a distance, the distance that we are taking, that is a minimum. We assume that once we reach from A to B, in-house processing of B is 0. So that's why, let's say if I go from A to B and B to D, the path distance is 3 plus 4. Okay, we are not taking in processing, let's say the packet that will be reached at B, the particular time from B to in and out, that we consider 0. So that's why the path here is 3 plus 4, that is 7. Now will this be a shortest path? Well, no, this won't be a shortest path. Our shortest path is actually from A to C and C to D. Now we can use the Disaster shortest path algorithm in this particular strategy, that's we can do it. So let's start with, well, the question obviously is why to use a backtracking method for this particular problem. Well, we already have a greedy algorithm, that is a disaster algorithm that already we have, that will take about n log n time to solve the particular problem. We will to kind of use the priority queue, and from the queue we will able to get it all the nodes, and from that we can use the algorithm steps from the greedy methods, and that will be a kind of within less time you will get the answers. But here, well, the backtracking is kind of a generalized approach, because as we said, or as we know, that the algorithm that may not be solvable by the techniques like greedy, divide and conquer and dynamic programming, that can be solved by backtracking. So it means also backtracking is also possible to the problems that is also solvable by gradient, divide and conquer and dynamic programming. The only thing is, as we have efficient algorithm available, that's why we are not resort to use the backtracking. But there is a connection between backtracking and that approach. So that's why we want to exploit that thing using this thing. So let's say the backtracking is a technique to solve all the problems. So it's like if you have exhaustive search available to search, let's say a city with many paths available, and now we are going to find a way, and we assume that you have a kind of in your particular vehicle unlimited amount of petrol or any other diesel or any other available, and then you can move here and there, and you have an infinite time is also available, and also you can able to get not one answer but maybe the possible more answers, that is also optimal. Yeah? So now if we have enough time, we have enough resources, we have also enough space, then we can use the backtracking. That is one thing. Yes, the backtracking is kind of a more complex, compared to this while using the gradient kind of thing. But before arriving to greedy, can we use a backtracking to find a solutions, and from that solutions we try to identify the patterns, and from patterns if we can conclude that this is a greedy method that is possible, then that's why this video is very helpful. So now this lecture is kind of a showcase that how to get a greedy method by analyzing the patterns and that patterns that we received from the backtracking. So what you can say, like in research what we do is that for some problem we will try to find a solutions, we will see the solutions, we will see a multiple solution if that is possible, then we will see the the patterns in that solution. Sorry. So once we have the patterns, then we will use the pattern analysis algorithms. We will use to see that what is common in these solutions, why we get these solutions, and from looking at the problem and the solutions, if we kind of getting a techniques that will be a very effective. So that is what a backtracking will give you all possible solutions, and that's why it's a very good fit to determine a technique if that is possible. So consider a backtracking is like intelligent naive methods, because we want a feasibility to be maintained every time in the backtracking. That's why it's not a simple method, but we consider intelligent naive method. So that's why we will try some intelligence, use the backtracking approach. So at when to start, when to stop, that is what the intelligence word is useful here. And from that we got all the solutions, and from all the solutions we got a patterns, and from the pattern analysis we will kind of getting what is our greedy method. So that is, you can say, the stepwise process: stage 1, stage 2, stage 3, and so on. So let's take our example of shortest path. Now what we want is, we want to generate a state space tree. Now for that, what is state space tree? You will refer my other videos that is particularly devoted on the state space trees and how to create the state space trees, and that is useful. So now you can see in the backtracking, if you have a state space tree of a given problem, from that you will get the solutions, and from the solution you will get the patterns. So from this particular graph we want to generate a state space tree, and from the state space tree we will get the pattern analysis. So let's look at the state space tree of this particular graph. So you can see, just for your understanding, I already given a graph here in a given size, so that will be useful to you. Our goal is to find the shortest path from A to D. So what we have to do, we have to start with the, of course, because we want to find the shortest path. Now what we have to do is, we have to see what is the outgoing edge from the A. Now it's undirected A, so that's why from A to C and A to B we have both the path. So let's try to explore with first, because in the backtracking you have to go with the depth first search. So this is the first path that is going on. Now again from the B there are two outgoing, of course B to A, but A is already visited, so that's why we are not going in the same, otherwise it's a loop and it's a cycle. And in the shortest path, if you again confused in the cycle, the positive edge is cycle, that it will again go and go and go on. So that's why. So again we will go from B to C, now C to D. Okay, because there is a path from C to D, that is C to D, and we can see if we take this path 3 plus 4 plus 1, total 8. We will stop at D because D is our destinations, because we want to find the shortest from A to D. Now 8 again, as there is, we don't have to go any further explore, we will backtrack here. We don't have any other sibling of C to be explored. Again we will backtrack here, we will see is there another sibling of the child of the B that is yet unexplored, that we can able to take here, B to D. We will come here, B to D. Now the moment we reach to D, we will see what is the path 3 plus 4, so we will go 7 here. Now and again, now we don't have to further explore because we reach our destination. That's why we don't, if we go further, it's unnecessary, we are not getting answers, as well as our path is going to be much more. So that's why this is kind of an intelligent naive method, that we don't want to explore further this tree. So that's why again we come here in the B, and once the B we will check out other than C and D, is there any unexplored child of B is yet there? No, there is no child. we will come to A. Now after A we will reach, we will explore another child of the A, that is the C. A to C, that is there. Again from C to B and B to D we will try to explore. We will get the answer total 10, that is the path. And again we will come back because we don't have to explore after we reach to the D. Once there is no any other sibling of B that is yet to be visited, and then here, and then the D, yes, we will got 3, and then we will come to here. Here, see, now there is no any path available that we can try to explore from C to other any outgoing edge. B and D both is explores. A is already the parent of C, so that's why there is no any need to go further. Further child, we will again come back here. So now that is our state space tree for this particular graph. Now you will see how we are getting a shortest path, we are getting a longest path. So 10, that is our longest path, 3, that is our shortest path. Now our approach is the shortest path. So what is the path here? A to C and C to D. Yeah, so this is our path. So let's go back to our graph. So what we got is here, first we will go to the A to C, that is our first, and from C to D. So we are not getting a distance only, we are getting the path too. And that's what we can try to use our greedy method, that we will take the shortest one. In the greedy, if you remember the disaster shortest path methods, from the A, it will take 2 and 3. So here there is 3 comma A and here 2 comma A, that will be there. Now after this the C will be selected because it's having a minimum, and from C again 2 plus 1, that is 3 here. So ultimately that is selecting a vertex that is kind of a near in that. So this why in this case we will kind of get a particular way that okay, that will try to follow the greedy methods. So that's why by analyzing the solutions from the state space tree we will come to know that okay, that will kind of follow a particular patterns, and then from patterns we will try to get the okay, this is kind of a greedy method that is possible. And once we know that this method is possible, we will try things. So now we will say that there is a kind of a connections between the backtracking and a kind of a greedy methods, that okay, in the backtracking you get the solutions, you will analyze the solutions, and you can kind of get okay, this is which methods, and try to see that how this method we can apply in solving this particular problem. So you, for a reference of referring the disaster algorithms, the greedy method, backtracking methods, you can refer the books as per the syllabus. Also you can refer the NPTEL videos, MIT, any other relevant material, as well as on the Google you can see. So you can kind of get a greedy methods, you can kind of get a backtracking. So this particular video lecture will be the bridge between these two to tell you that also in our upcoming video lectures we will see more examples that will try to first solve using the backtracking. We will generate a state space tree, and we will see that from the tree we can kind of getting from the solutions what is the pattern analysis, and then from that we will try whether other technique of algorithms can be possible to generate that particular solution. That is what the things. Okay, again, so the greedy will give you the one possible solution. If there are multiple solutions, then you have to use the backtracking, that will give you all solutions. But on the other hand, backtracking will take much more time, much more energy, much more space. That's what you have to be deal with if you want all the solutions. Thank you for watching this video, and I hope that this video will be helpful to you in creating a bridge between these two techniques. Thank you.